Okay, so remember you get all your formulas and everything that you need. You'll have a basic red calculator. Okay. Mm-hmm. Yeah, do you want a red one or a graphing? Well, you can just grab one of those over there if you want. In the cell phone motto there, there's a couple. Okay, yep. Do you need a test for frequency? Does everybody else have a test for you? There you go. Mm-hmm. All right. So number 7 is where we left off yesterday. It says the table below lists the number of albums by the Beatles that received sales certifications. So the certification and then the number of albums that got them that certification. We're going to make the Pareto chart, which kind of looks like our bar graph, and then we're going to make a pie chart also below in a minute. All right, so anytime you are making any sort of graph, you want to make sure you label your axes. So in this case, our certifications are going to make up our categories. So those are going to go at the bottom. And then the number of albums is going to go on my vertical axis there. Okay, as far as the vertical axis goes, I need to get all the way up to 48. So if I start at 0, maybe if I count by tens, but you can count by whatever you want. That's just kind of personal preference. So 0, 10, 20, 30, 40, 50, and we're just sketching here. We don't have to use a ruler or anything, so just do the best you can to make those equally spaced. Okay, and then as far as the bars go on this specific type of chart, remember your bars are going to be in decreasing order. So they're always going to start with the highest one, go down from there. The bars do not touch when you're drawing these. Okay, so the highest one I have is gold. Then I have platinum. Then I have multi-platinum, just abbreviating here. And then my last one is diamond. Okay. So my first one's going to go up to 48. Again, do the best you can to make this look like a rectangle. Yours will probably look better than mine. Okay. Platinum is up to 42. Multi-platinum, 26. Okay, and then diamond is at 6, something like that. And you can fill them in if you want. Okay. Good on that one? Okay. To make the pie chart, we have to first calculate what degree each of these categories is going to represent out of the total 360. So if you remember doing that in class, we first found the relative frequency. So I'll make like some extra little columns here. So relative frequency was your frequency f divided by n, which was your total number of data values, whatever you have here. So we do need to figure out that first. If you sum up this column, you'll get your n. So 6, 26, 42, 48, I'm at 122. Okay, so then for each category, we're going to do the frequencies. So for the first one, it'll be 6. Sorry, ignore the beep. Divided by my n, 122, and we'll round to like 3 decimal places for this. I get 0.049. Then, if you want to do it all the way across, kind of like we did with some of those other tables, you can then figure out your degree by just multiplying by 360. So take your frequency, multiply by 360. I'm just going to round to the nearest degree, and that is 17.7, so I'm going to say 18 degrees will be that piece of the pie. Okay, and then we're going to do that for the rest of the category. So 26 out of 122 gives me 0.213. multiply it by 360 to the nearest degree, 77 degrees. 42 over 360, 0.117. Oh, I did divide by 360. Why did I do that? Divide by 122. Hold on. Let's try that again. 0.344, that's better. Times 360. I get 123.9, so we'll say 124. And 48 over 122, 0.393 times 360. And it's about 142 degrees. That last column might not round up or sum up to 360. Might be slightly over or slightly under just because we rounded all those degree values to the nearest degree, but it should be pretty close to 360 in that last column. Okay, good there? All right, so now we're going to take those and create the pie chart. Yours is right below on your paper. I'm going to start with the biggest one. The biggest one was 142 degrees. So how I like to start it is I'm just going to draw a horizontal line. I know if I complete that diameter on the other side, that's 180 degrees. So I need to be a little shy of that, somewhere between 90 and 180. Again, this is just a rough estimate, maybe somewhere like there. And was that the platinum, gold? Which one was that? That was gold. Was the big one? It was gold. Okay. All right. And then what was my next highest one? Platinum was 124. So you can do kind of the same sort of estimate using the top. So if I drew a line directly up, that would be a 90-degree angle. I need 124, so I'm going to draw it a little out from there. Maybe there. And that was our platinum, multi-platinum. Platinum. Okay. All right, then multi-platinum was 77 degrees. Oh, I don't know. Maybe something like that. And then the last one was diamond. Okay. And then you can label it number of albums. For these certifications. Okay. All right, questions making pie chart. Great. Okay, number 8 is a weighted mean that we're calculating. It says the scores for statistics students are given below. If homework is weighted 5%, quiz is 35%, projects 35%, final exam 25%, what is the student's mean score? Okay, so the formula that we used for this was the sum of all the x values times their weights divided by the sum of their weights. That's how we calculate a weighted mean. So what that means is in the numerator, we're going to take all of our categories, our x's, and we're going to multiply by their respective weights. So homework, 85, and its weight is 5%. And then we're summing all of these up. So plus quizzes, 80 times its weight, 35%. Projects, 100, 35%. And final exam, 93, and that was 25%. In my denominator, I'm dividing by all of the weights. Plus 0.35, plus 0.25, and ideally if this is calculating a grade, the sum of those weights is going to end up being 1, which it is here. So really you're just calculating the numerator. And you can type that all in your calculator once if you want. Okay, so I got 90.5 over 1 So 90.5% would be the final grade for the student. Okay. Questions on number 8? No? Okay. Moving on. Okay, so number 9. This is our frequency distribution table that we're going to create. We're going to use the following data set. This represents class sizes for 20 national universities. We're going to get all those class limits, frequencies, midpoints, boundaries, relative frequency, cumulative frequency, all the little pieces and parts. Okay, so the first thing we need to figure out is we have to use 5 classes. So we need to figure out what our class size is going to be, our class width is going to be. So to do that, we're going to calculate our range first. We did this yesterday. So range is our highest value minus our lowest value. What's our highest value here? 55 minus our lowest value is 26, yep. 26, and then if I subtract those, I get 29. Sound good? Okay. So then we're going to take our range, divide it by how many classes we have, and then you always, no matter what this number is, round up. We're rounding up, so we make sure that eventually all of our data is going to fit in the class limits that we create. So 29 over 5 is going to give me 5.8. So if I round that up, even if it was 5.1, I would round it up to 6. So that's how many data values are going to be in each of our classes. Okay, so I am going to create the classes first, and then we'll tally them up here. So my lowest value that we had was 26. If you want your class width to be 6, you're going to add 6 to that over and over again, and that's going to be the start of each class. So 26 plus 6 gives me 32. That's going to be the next class. Then 38, then 44, then 50. And then where one class stops, the next one begins. So if the second class starts at 32, that means the first class ended at 31, and you could always count on your fingers, 26, 27, 28, 29, 30, 31. There are 6 numbers in that class. That's what we're looking for. So the next one goes to 37, 43, 49, and you can see the same things happening on the right side there. We're just adding 6 over and over again to where the limits end. So if I add 6 to that 49, I get 55 is going to be my last one. Okay, so now frequencies, we're just going to tally them up. You can cross them out as you go, and we want to make sure at the end that the sum of our frequencies is 20, which means we've accounted for all the data that we knew we had to start. That was our n. Okay, so numbers that are between 26 and 31. I've got 1, 2, 3, 4. Okay. 5. Did I miss one? What did I miss? 30. Oh, yep. Thank you. All right, 32 to 37. 1, 2, 3, 4. Excuse me. 38 to 43. 1, 2, 3, 4, 5, 6. 44 to 49. 1, 2, 3. And then 50 to 55, looks like I've got 2 left. Make sure I've accounted for everybody. There are 20 there. Okay. All right, midpoints of each class, add up the ends, divide by 2. So 26 plus 31, divide by 2. Finding a midpoint, finding an average there. It's going to give me 28.5. 32 plus 37, divided by 2. Gives me 34.5. 38 plus 43 divided by 2, 40.5. What do you notice is happening with those numbers? They're increasing again by the class width. So you can save yourself some time, 46.5, 52.5. Okay. Class boundaries are where we take our classes that we have, the upper limit and lower limit, and go a half a unit in either direction. So this ensures that where one starts, the next one stops, or vice versa. So instead of 26 to 31, my boundaries will be a half a unit lower, 25.5, and then a half a unit higher, 31.5. And you're just going to do that for each class. So 31.5, 37.5, 37.5, 43.5, 43.5, 49.5, 49.5, and 55.5. Okay. Relative frequency is what we did with our pie chart a few minutes ago. It's our frequency divided by n. So for that first one, 5 over 20, that's going to give me 0.25 exactly. 4 over 20 is going to give me 0.2. 6 over 20 is going to give me 0.3. 3 over 20, 0.15. 2 over 20, 0.1. And if you want to, you can check these. Your relative frequencies should always sum up to 1 at the end because they represent percentages. Cumulative frequency is what we use for those Ogive graphs. It's where we take the frequency of the first class, which here we have the frequency of our first class is 5. And then we just continually add to that with the frequencies of the next classes. So the next cumulative frequency value, if I add in that 4, would be 9. Then I would have 15, 18, and then the last value there should always be your n in your cumulative frequency column. Okay, so I think that accounts for everything we needed there. Good? Questions? Yes. So the first class had a frequency of 5, so that one always is where you start at. And then I'm just adding in these other frequencies. So if I'm looking at the second class, I include this class's frequency and all the ones before it. So here would be 9. So I'm looking at this one, and all the ones before it. So you're really just adding in the next frequencies as you work it out. Anything else on the top here? Okay, so now some graphs we can do at the bottom. We're going to make a relative frequency histogram using the numbers that we have, and then we're also going to make an Ogive graph. Okay, so we're going to label. Let's start with the relative frequency is what we're making. Now, relative frequency are the percentages that we have. The percentages that we had in this chart went all the way from 0.1 to 0.3 was my highest. So if I start counting at 0, 0.1, 0.2, 0.3, that'll do it. This was average class size. So that's what I'm going to label my horizontal axis. And this is where you can decide what works best for you as far as the ends of the histogram go. When I make a histogram, because the bars touch, I like to use the class boundaries, because if I use the class boundaries, those are going to be the edges of my bars, and that'll ensure that where one stops, the next one begins. So I'm going to make this with class boundaries. Now there is going to be a little break here because it's not going to start at 0. And the first class boundary we had was 25.5. The next one we had was 31.5. These just increased by 6. 37.5, 43.5, 49.5. If I can squeeze in the last one there, was 55.5. Okay. All right, and then you're just going to make your bars go up to whatever their respective frequencies are. So my first three are 0.25, 0.2, and 0.3. All right, so 0.25, 0.2, and 0.3. And again, you can fill them in if you want to. And then my last two were 0.15 and 0.1. All right, for the second graph, we're making an Ogive graph, which an Ogive graph is cumulative frequency, is what you're going to label the side there. Again, your horizontal axis is going to be the average class size. And you can use the class boundaries again for this one, are fine. You can also use midpoints was the other way you could graph these. If you use midpoints, though, when you make an Ogive graph, you have to go one midpoint in addition to the ones you have in either direction, because our Ogive graph always has to start at 0. So I like the boundaries because at 25.5, that's before any of our data has started, so that ensures that we start at 0 when we make this. 31.5, 37.5, 43.5, 49.5, and 55.5. Now, cumulative frequency was that last column in your chart, so you're going to have to get up to 20. So we're going to number this axis a little bit different. Start at 0. You can count by, I don't know, 2s or 5s, whatever you want. 8, 12, 16, 20. Okay, I'll do this part in a different color maybe. All right, so always starts at 0. My first class had, was it 5? It had? Okay, so at 31.5, after that first class has ended, we're at 5. Then at 37.5, I believe we got up to 9. Look there. 43.5, what were we at for that third class? 5, 9, 15. The next one. And then we were at 1820 for the last two. 18 and 20. Something like that. Okay. All right, so questions on anything to do with our frequency distribution, columns that go with it, graphs we can make from it, any of that stuff. No? Okay. Give you guys a second on that one, then we'll do those last couple on the back. That'll be it. All right. So number 10, a child's height is in the 47th percentile on the growth chart. What percent of children are taller and what percent of children are shorter than this child? When you are in a certain percentile, that exact number is how many are below you. That's how percentiles are measured. So the percent below this child is 47%, which means this child is technically number 48 in the list, okay? So what percent is above them if they're number 48? Close? It's going to be 52%. Above is going to be 52%, okay? Again, because they're number 48 of 100, if you want to think of it that way. Questions on that? Okay. Again, here we have a mean that we're going to calculate using weights, a weighted mean. So we're going to use that same formula again we did with the grade problem earlier. The sum of all our x values times their weights divided by the sum of all of the weights. All right, so here we have a little bit of a problem because we don't know exactly what the weights are. We just have classes. So what we're going to do is use the midpoints of those classes as our x values. Okay. So, and you can think of the frequency when we do this as the weights. All right, so the midpoint of 118 and 126 is, if you add them up and divide by 2, 122. 127 to 135, the midpoint is 131. Between 136 and 144, my midpoint is 140, and you guys can see the same things happening here that was happening with our frequency table. They're increasing by 9, so you can just follow that pattern all the way down if you want. 149, 158, 167, 176. Okay, so now according to our formula, we're going to take all the x values times their weights, which are their frequencies in this case. So that's going to take a minute. 122 times 3 plus 131 times 5 plus 140 times 9 plus 149 times 12 plus 158 times 5 plus 167 times 4 plus 176 times 2. That's my numerator. Divided by the sum of all the weights, the sum of all the frequencies. You can write them all out there if you want to, or you could just sum up your frequency column. That's going to end up being the sum of all the weights here, which is 3, 5, 9, 12, 5, 4, and 2. The sum of all of those frequencies are 40. And then do your calculation. All right, so on top I get 5879 over 40. 146 point, oh, I don't even need to say approximate. I don't have to round it. 0.975. I want to give an exact one. Okay. Good there? Okay, last one. All we're doing here is just completing for the box and whisker plot the percentages that are going to be in each of those ranges, and then for the bell curve we're going to give the percentages that fall within each of those standard deviations. So we talked about this yesterday. For each piece of box and whisker plot, a whisker or half of a box, what percent is there? 25%. So that's all we need to put in each of these. So if you wanted to know what percent is in the inner quartile range, it would be 50%. What percent is in the whiskers? 50%. What percent is above the lower quartile? We could say 75%. You're just going to add up all those regions. Okay, the bell curve, this is the empirical rule we were practicing a little bit with yesterday. Those lines didn't show up super great, it looks like. So you can put those in there if you want. Go. Okay, so in the mean where it says 0, that's always your x bar. In the middle there. Okay. Within one standard deviation is what percent? Within one standard deviation total is 68. And then you can always break that down into pieces and say that 34 and 34 are on the left and the right. Okay. Within 2 standard deviations is what percent? So the little bits are going to be 13.5 in each piece there. And then what's the total now between those arrows? Plus the 68 you have already, 95%. Okay, and then the last one is 97.5%. That was our empirical rule. That's going to be within 3 standard deviations. And what were those last little percentages? 1.25, 1.35, something like that. Must be 1.25. right? No, that's not right. I've got 2.5. 2.35. It might be when we look at that. That 99.5 might be a little bit of a underestimation. Technically, it would be. No. I think it was 97.5 total, or it's 99.5. That's why my brain isn't working. 2.35. All right. So if you were asked a question about what percent of the data is above a value that is at 1 standard deviation to the right. So I want to know what percent is above this value. Well, from my mean to the right, what percent is located there? From the mean to everything to the right. What total? It's the mean, so it's 50%. So we're talking about a bell curve. So if I want to know what percentage to the right here, we don't just want to add up these two little percentages. There's something else beyond the 3 standard deviations. So what you want to do is you want to think I've got 50% here, but I need to take away this 34%. It's everything else. So if I do 50, take away 34, from 1 standard deviation to the right is 16% of my data. So use it. And when we get to chapter 4, I think is where we start actually using it, we're going to have a chart. It's called a Z-score chart that tells us exactly where we're located and what percent is to the left and to the right of it. So we're going to get values like, I don't know, -0.67, and we'll have a chart, a data set that we can look up and use the row and the column, find that number, and figure out exactly what percent is above or below. So for right now, we're just using like these nice, pretty round numbers with the integer tool, but we'll eventually get to some smaller values that we'll be able to calculate also. Okay. All right. So this is everything you need to know for your test. Tomorrow and Monday, the problems will be scrambled a little bit, so not necessarily the first 6 are what you're going to see on Friday, and the last 6 are what you're going to see on Monday. So make sure you're looking over everything tonight. You guys also have an extra practice test if you want to do some extra problems. Solutions are posted. That's all in Polaris for you. You have your circuit training. You can turn that in tomorrow if you want the bonus ticket. Okay? Good? Anything else for good of the order? All right. So the last little bit of the period is yours here. I'll do cell phone lotto. And then we are done. We're done.